Okay, so I've had lots of questions about this kind of problem, so I'm going to work it for you. The first thing I would do is if I had an equation with a fraction in it, or any fractions in it, I would get rid of the fractions. So before you even start solving it, get rid of the fractions. You do that by multiplying every term. Notice that the first top equation has 3 terms. I'm going to multiply every term by the common denominator, which in this case is 12. So when I simplify this is going to be 3x plus 10y equals 60. And I'm going to do the same thing in the bottom. So I'm going to multiply all 3 of those terms by 5, which is going to give me 6x plus 20y equals 120. All right, now if I were going to use the process of substitution or elimination, I'm going to look at this and probably think the easiest thing to do is elimination. And in order to get opposites, I would need to multiply the top equation, or you can do it a variety of ways, but I'm going to multiply that top equation by -2 to get my opposite with the x's. So that's going to give me -6x minus 20y equals -120. And on the bottom, I'm leaving that the same. So that's going to be 6x plus 20y equals 120. Now, when I add these two equations, notice I get 0 equals 0. And you might have recognized that these two equations were equivalent to begin with. We call these equivalent equations because, like if I had multiplied the top one by 2, I would have gotten the same one as the second equation. All right, so the big question has been, how do I write this in a solution? So since 0 equals 0 is a true statement, I know that it wouldn't matter what I plugged in for x and y. It would satisfy both of these equations because they're equivalent. How do I write infinitely many solutions? Well, you write x as your x coordinate. And that just means, and then you've got to remember that x is your independent variable. You could plug anything you would want to in for x. Now, what's y going to be? Well, y is going to be based on you solving that for y. So just solve one of the equations, and you can go back to one of your original equations, but I would just use the one that I'd already gotten rid of the fractions in. So, for example, if I look at 3x plus 10y equals 60, if I isolate y or solve this for y, I get 10y equals 60 minus 3x. And at that point, I would divide by 10. And so y is going to equal 6 minus 3x over 10. So that's going to be what I use for my y coordinate, 6 minus 3x over 10. So once again, in order to write your solution for infinitely many solutions, you just use x for your x coordinate and then solve for y in one of the equations, and it doesn't matter which one because they're equivalent, and that will give you your y coordinate.